Okay, Algebra 2. This is the note sheet you have in front of you, and we're going to learn how to graph square roots and cube roots. So the first thing we're going to do is just make an XY chart to get an idea of what this looks like. So what are we going to plug in here for X that will be easy things to plug in? 0 is good. We plug in 0, we get 0. We can plug in 1 for X. We plug in 1. We get the square root of 1, which is 1. So 1, 1 is a good point. Okay, how about 2? Is 2 a good point? If we plug in x equals 2, we get the square root of 2, and that's not easy to plot. So we're not going to plug in 2. What are we going to plug in next? You got it. We're going to plug in 4. So if we plug in 4 for x, then we get y equals the square root of 4, which is 2. So 1, 2, 3, 4, and go up 2. Now how about negatives? Can we plug in some negatives for x? What happens if we plug in -1 or -4 or negative whatever for x? That's right, you cannot square root a negative. So any negatives like -1, -4, negative anything will give you no real solutions. So hopefully you can see now that we won't be able to go over to the left here on the negative side, and we will just have a graph that curves out like this. Okay, and hopefully you notice, well, that kind of looks like half a parabola, and it is. That is the positive side. There's the negative side of x squared flipped over, flipped around. Okay, so you'll notice this is the opposite of x squared. X squared looks like this. This is turned on its side. Okay, so let's look at x cubed, or the cube root of x. What do you think this is going to look like? Well, this is going to be the opposite of x cubed, which hopefully you remember looks like this. Okay, so let's try some values. What can we plug in for x? Well, yes, we can plug in 0. We get 0, 0. What if we plug in 1? What's the cube root of 1? Yes, it is 1. What else can we plug in? Remember, we want to plug in cubes that will be easy for us to use. We don't want to get something strange and hard. So what else can what's the next perfect cube I can put in here? How about 8? Cube root of 8 is 2. So 8, 2 is a point. Okay, how about the negative side here? Can we plug in a -1? Well, of course we can, because we can take a negative root. So if we plug in -1, the cube root of -1 is -1. So we're right here. And the next perfect cube we can plug in is the cube root, or -8. Cube root of -8 is -2. So here we are with cube root of -8 is -2. So hopefully you can see, well, here's x cubed. Cube root of x is very similar, but kind of flipped on its side. Okay, so what we're going to do now is add in some a's, some h's, and k's like we did in other graphs so far. Okay, and you'll notice that h is always under the root. H is under the root. And then where is K? K is out to the right. They haven't moved from other times we have used them this year. So H is always with the X, wherever that is, and the K is out by itself. Okay, so the directions are there, but I'm going to walk you through this. So now we turn to this first example. Now, unfortunately, I don't really care for that example, and so we're going to write a new one. So, scratch that out, and in its place, if you would, please write f of x equals 3 cube root of x minus 1 plus 2. Okay, so that's the function that we want to use today. So, first thing we need to do is decide what h and k are. Remember, h always lies, and h is under the square root with the x. So h comes from this right here, and h is 1. K is out here by itself, and k is 2. So over 1 up 2, that's going to be our starting point. And then this graph is just going to curve out that way. So how are we going to figure out exactly where it curves? Well, we're going to pick some points. So to do that, we need to think pretty logically. Okay, we know we want to take perfect squares here. The square root is not easy to deal with, so let's put in easy numbers to do that. So what happens if we put in the number 2? Let's see, if we put in 0, we get -1 under there, and that won't work. If we put in 1, oh wait, we already put in 1. We already found the point 1, 2. That was the edge. What if we put in 2? 2 minus 1 is 1. Oh, well, that's pretty good. So let's find y when we put in 2. We're going to have 3 times square root of 2 minus 1 plus 2. 2 minus 1 is 1. So we have 3 square root 1 plus 2. 3 times 1 plus 2 is 5. So 2, 5 will be a point. So put down 2, 5. Now let's find another one. 3 minus 1 is 2. That's not going to be good. 4 minus 1 is 3. That's not very good. How about 5? What if we plug in 5? We get y equals 3 square root 5 minus 1 plus 2. 5 minus 1, oh, that's 4. So we have 3 times square root of 4, which is 2, plus 2, we get 8. So 5, 8. So we're going to go over 5 and up 8. Okay, and so we know this is our starting point here. So we've got this big, this big curve right there. Okay, and don't worry about domain and range for now. We'll do that in class. Okay, so now number 2. Let's do this one, and we can keep this problem as it is. I don't mind this problem like it is. And let's find hk. Remember, h is under the root with the x. So in this case, I'm going to change colors here so that things aren't all mixed up. H is in here with the x. That's 0. And k is out here by itself. That's -3. So our first point we found is 0, -3. Okay, and that's going to be this point right there. That's the 0, -3. So we need to find some other points. So what can I plug in for x? Well, this one's easier than the last because I can just plug in any perfect square. So I'm going to plug in 1. So now I have y equals -2 times the square root of 1 minus 3, which is going to be -2 minus 3, which is -5. So I get 1, -5. And what else can I plug in? Well, the next perfect square is 4. I don't know why I wrote 5, because it's 4. So now we have -2 times the square root of 4 minus 3. Y equals -2 times 2 is -4 minus 3, which is -7. So we're going to go 4, -7. Okay, and this actually looks a little bit different because it's flipped this way. What makes something flip over? A negative out front. All these rules are hopefully coming back to you. So that negative out front is what makes it flip over. Instead of being the top half, it is now the bottom half of the parabola. Okay, let's do this last one, or the last one we're going to do together. And this is a cube root. So this is a little bit different. So, oh yeah, I want to change this one too. So let's make this f of x equals 2 times the cube root of x plus 3. Okay, so h lies and h is under the root. So in this case, h is -3. and k is out by itself, and since there's nothing out by itself, that is 0. So we have 1 point, and it is -3, 0. And if you remember what this looks like, that is this center piece right here. So now we need some points to the right of that, and we need some points to the left of that. Okay, so the key here is trying to figure out what is going to make a perfect cube inside there so that it's easy for us to deal with, so we can do this without a calculator. Okay, well, what are our perfect cubes? Our perfect cubes are 0, 1, 8, -1, -8. We go up to 27, but most of our graphs don't go to 27. So under this perfect cube, I need to make 0. Oh, well, I already did that right here with -3. Make 1. How can I make 1 here? Well, then x needs to be -2. If x is -2, then I have y equals 2, cube root -2 plus 3. -2 plus 3, that's 1. Cube root of 1 is 1, so we just get 2. So -2, +2. And I forgot to plot that first point of -3, 0. So let's make sure that we plot -3, 0. Okay, these are pretty close together. So let's get some more points here so that we know what is going on. All right, so what else can we plug in? We made this in here a 1. Now let's make it an 8. How can I make it an 8 inside here? You guessed it, I'm going to plug in 5. So I'm going to plug in 5 for x. So we get y equals 2 times cube root of 5 plus 3. 5 plus 3 is 8. Cube root of 8 is 2. 2 times 2 is 4. So I just found the point, 5, 4. So go ahead and plot that. All right, so we can see what the right side of this is doing, but we got to get over to the left side, which means I need some of these negative perfect cube. So how can I make this inside here a -1? How can I make the cube root of x plus 3? How do I make that inside there a -1? That's right, I have to plug in -4. So we have y equals 2 times the cube root of -4 plus 3. Cube root of -4 plus 3, well, that's 2 times the cube root of -1, so that's going to be -2. -4, -2. Okay, same thing. We need to find a perfect cube in here to be -8. Okay, so how am I going to make this a -8? Well, I'm going to need that to be -11. So we're going to have y equals 2 times the cube root -11 plus 3, which is going to be -8. So 2 times the cube root -8, 2 times -2, -4. So -11, -4. And hopefully now that's enough to see the S-shaped pattern here, which is right there. Okay, so go ahead and attempt number 4, see what you can do with that, and we will definitely talk more about these in class. Have a great day.